Behind the quiet terminal, the engineer realized that many technologies appearing today had actually been imagined decades earlier. The workers aged 22 to 25 inspected each metallic panel beneath the stable white lights, while old blueprints were still preserved. Inside the disciplined space behind the terminal, every human movement was slow and precise, as if the entire male engineer looked into the open jet engine and realized that even the shape of a modern aircraft was the result of ideas that had begun.
The female engineer placed her hand on the maintenance data screen and realized that aviation never develops at the speed of short-term.
The young workers continued replacing each small component with absolute concentration because they understood that even a tiny change on an aircraft could take decades to be fully accepted. The narrow-body aircraft in matte gray metallic color rested beneath the cold lights and created the feeling that it was.
The question began to grow clearer.
The male engineer reopened old design documents and explained that under normal operating conditions, a commercial aircraft had to survive.
The female engineer continued monitoring maintenance data and realized that any technological change had to remain compatible with. The young workers inspected wiring systems inside the technical compartment, while every safety standard continued to be maintained. In aviation, stability is always prioritized over the speed of innovation, because a small mistake on the ground can become. A new aircraft model not only needed to fly, but also had to prove stable operation in countless weather and environmental conditions.
The female engineer looked at the maintenance schedule extending across many decades and understood that the lifespan of an aircraft forced every.
The young workers replaced each small component according to strict procedures, because they knew that any change also had to remain compatible with the training systems. The quiet atmosphere inside the maintenance hangar revealed a truth that aviation could never change as quickly as ordinary consumer technology industries. The male engineer explained that every new technology appearing on an aircraft had to go through long periods of testing to ensure that it would never create risks for millions of future flights. The female engineer began to understand that the future of aviation was not built from ideas appearing suddenly, but from very long plans prepared far in advance. But that itself created a major contradiction, because the outside world was always changing much faster than the pace of aviation development.
Many technologies being tested today might still need 10 or 20 more years before becoming widely used.
The South Asian female engineer questioned why aviation still could not apply technology immediately onto commercial aircraft, even when that technology already existed.
The young workers continued working in disciplined silence, while today's aircraft still relied on many design principles created decades ago.
The wrong sites. The contradiction became clearer as passengers constantly demanded aircraft that were more modern and more fuel efficient.
The male engineer explained that aviation had no simple concept of trial and error like other industries, because every mistake was directly connected to human lives.
Changing only a tiny detail could trigger thousands of new inspection and certification procedures.
The young workers polished every metallic surface beneath the white lights, while automated inspection systems continued operating without interruption. Aviation wanted to move forward, while at the same time being forced to keep everything absolutely stable for very long periods. The male engineer began to understand that the extremely high demand for safety had forced aviation to think in cycles longer than any other industry.
That meant any technology developed today had to be calculated to remain suitable for the world many years later, and not only for the present.
The male engineer explained that aircraft manufacturers did not design for tomorrow, but for an entire future generation of passengers. We are approaching maximum load. Monitor the data closely. Adjusting the sensor array now.
The female engineer realized that the long certification process forced every new idea to be predicted far in advance.
A fuel-efficient engine technology could not be created within only a few years because it needed to go through countless cycles of testing. The male engineer looked at old aerodynamic data and understood that many studies from decades earlier were becoming the foundation for today's modern aircraft designs.
Aviation begins from the future very early, Because the development time of an aircraft is always much longer than the public imagination.
The female engineer explained that even airport infrastructure, pilot training, supply chains, and maintenance systems needed many years to adapt to new technology.
At this point, the central question finally had a clear answer, because the entire aviation industry was forced to prepare for the future very early.
The male engineer began comparing aviation with consumer technology industries and realized that the biggest difference lay in the speed of risk acceptance.
Smartphones can be updated every year, but an aircraft cannot continuously redesign itself while carrying hundreds of passengers in the sky.
The female engineer looked into the technical database and saw that aviation always had to balance technological innovation.
The young workers continued maintaining each small component, while the most advanced modern technologies were still.
The difference in aviation lies in the fact that the industry is never allowed to fail publicly, because every failure can destroy society's trust.
This was why manufacturers always had to think decades ahead in order to minimize risk before new technology officially appeared.
The African-American female engineer realized that the future of aviation was not a race to become the fastest, but a race to become the most stable and precise.
The narrow-body aircraft in matte gray metallic color rested quietly inside the maintenance hangar, as proof that many The male engineer understood that aviation moved slowly not because it was outdated, but because it carried a greater responsibility than any other industry. The young workers completed the final shift of the day, while the sounds of inspection machines still echoed steadily through the clean, quiet space behind the terminal. Future aviation begins decades earlier because humanity needs enormous amounts of time to transform an idea into something safe enough to enter the sky.
The true future was never created at the moment it appeared, but through silent preparation lasting across generations.
The female engineer looked one final time at the matte gray metallic aircraft and realized that what made aviation's fuselage looks perfect. No anomalies detected.
Data confirms it. Closing the shift report now.
The safe skies of the future always begin with people willing to work for results they may not fully witness for many years. The male engineer and the female engineer stood silently inside the quiet space behind the terminal and understood that
lines. The narrow-body aircraft in matte gray metallic color remained motionless beneath the cold white lights, as a symbol that